All right, ladies and gentlemen, this is Mr. Heeren talking about 2.5 and 2.6 together. So I'm going to kind of chop some things out of here just in the interest of time. But there's a lot of key points in here I want you guys to pay attention to. First off, finding sine, cosine, tangent, and then cosecant, secant, cotangent. And then approximate the trig value of an angle. Finding exact sine, cosine, all those functions in the unit circle. So just kind of being able to find anything and everything in the unit circle when we go. So now let's just kind of back up here a second and review, because if you remember, oh so long ago before everyone was stuck at home, we talked a little bit about cosecant, secant, and cotangent. So let's kind of think about this. So we've got a point X and Y on the unit circle, okay, whatever it is. And we know that the radius is going to be 1. We know that it creates a right triangle back to the x-axis. And we know, like I said, we know the radius is 1. So remember, it goes SOHCAHTOA. All right, remember in your functions, it goes cosine and sine. Okay, that's kind of the way that ends up. So, this would be your x, this would be your y. All right, I don't know if you can see that very well, but your cosine is x and your sine is y. This part on the vertical or horizontal is going to be your x. That's going to be your y. So the sine of that function of that triangle, sine of t, would be y over 1. So it would just be y. Cosine is going to be x over 1. So that's just going to be x. Now, what does tangent look like? Well, if I look from my angle, you go opposite over adjacent here, that's going to be y over x. And then another way to write that would be to put sine over cosine. Okay, so sine over cosine is equal to tangent. Okay, so all I did, opposite over adjacent from this right triangle, that's y, that's x, that's 1. Opposite over adjacent, that's how I got tangent. I'm calling this t, by the way. So cosecant, remember, just flips it over. Okay, so cosecant is just sine flipped over. Remember, it's just 1 over sine of t. So instead of y, this is just going to be 1 over y. All right. Secant is just going to be 1 over cosine, so that's just going to be 1 over x. All right, all you're doing is flipping it over. So tangent or cotangent and tangent are going to be reciprocals of each other. So this just becomes x over y, which is another way of saying cosine of t over sine of t. Okay, so take a second, hit pause, write down what you need to write down out of there before we go on. But just kind of realize sine is your y, cosine is your x. When I flip them over, that's what they look like. And then tangent ends up being just sine over cosine. That's kind of the big punchline here. Okay, so filling in this chart, it's going to be helpful for you to have your unit circle, especially when you're kind of looking at what your how you're trying to fill this in. So if I go on the left side, let's just kind of look. At degree of 0, that is at 1, 0. 30 degrees, that is 3 square root of 3 over 2, and then 1/2. 45 is going to be square root of 2 over 2, square root of 2 over 2. Skip that one, sorry. 60 degrees is going to be 1/2 square root of 3 over 2. Remember, just reciprocal of 30. And then 90 degrees is just going to be 0 and 1. So now remember, it all goes cosine, sine. Okay, that's your big punchline here. So as we go through here and fill this out, it shouldn't take very long to do. So real quick, convert them to radians. So at 0, that is pi over 6, pi over 4, pi over 3, and this is going to be pi over 2. Notice I'm doing just the first quadrant, because if I can do the first quadrant, I can do everything else. And I don't want to do everything else all at once because we'd be here all day, and I don't want to, even though I know we don't have a whole lot of, we have plenty of time. So as we kind of go through here, let's look. 0 degrees, what's my sine function? 0. My cosine is going to be 1. I got that from over here, cosine, sine. So remember, tangent is just going to be sine over cosine. That's a terrible. This is just going to be sine over cosine. So it's just going to be 0 over 1, so just 0. Cotangent is flip that over, 1 over 0. But I can't do that, so we call that undefined. All right, so just as kind of a reference, what I'm looking at, secant is going to be 1 over cosine. Cosecant is going to be 1 over sine. So secant, 1 over 1, is just going to be 1. All right, secant matches up to cosine, so 1 over 1. Cosecant matches up to sine, so 1 over 0, and that's undefined. All right, so now all I did, plug those in, okay? Sine is your x, or cosine is your x, sine is your y, and then just kind of filled it in from there. So for 30 degrees, sine is going to be 1/2. Cosine is going to be square root of 3 over 2. So then when I put this in here for tangent, I get 1/2 over square root of 3 over 2, which is a big mess. But if I multiply both top and bottom by 2, I get 1 over square root of 3. Rationalize that. So I get square root of 3 over 3. Now I know I skipped a couple fraction steps, but there's where I end up, square root of 3 over 3. So cotangent, flip that over, 3 over square root of 3, which ends up just being square root of 3. So then if I flip this one over, that's 2 over square root of 3, which again, after you rationalize, it just becomes 2 square root of 3 over 3. And cosecant means just flip over sine, so that becomes 2 over 1, or just 2. Okay, all I'm doing a lot of that rationalizing the denominator stuff that we were talking about way back in Unit 1. Okay, so that's all I'm doing for those that maybe you have questions about. So we're moving right along, so we're doing pretty well. So let's look at 45. So 45 sine, remember, is going to be your y value, so square root of 2 over 2. Cosine, square root of 2 over 2. Tangent, remember, is sine over cosine, so that just becomes 1. Then if I flip over 1, you get 1. So then, to flip over secant, you end up with you'd take 1 over that, so you'd get this. Okay, let me back up, because I think I might be confusing people. So if I go secant of 45, that's saying 1 over cosine. So that's saying 1 over square root of 2 over 2. Okay, so you have fraction within a fraction. How do you get rid of that? You multiply both the top and bottom by the bottom and the bottom. So you multiply both top and bottom by 2 because that cancels out. You end up with 2 over square root of 2. Okay, and that's kind of what I did up here and here. All right, so now I rationalize. So 2 square root of 2 over 2 leaves me with just that. So my answer here is just square root of 2. And the same thing here is that. So a lot of fraction rules come into play, okay? So I have fraction within a fraction, so I got to multiply top and bottom by the bottom and make it into one fraction, then kind of work from there. So that's kind of what that's going to look like. 60 degrees ends up looking almost like a reflection of 30 degrees, right? So which should make sense because like these 2 points are reflections of these 2 points. So it should kind of make sense that 60 degrees follows a reflection of 30 degrees. So this ends up being square root of 3, which matches up here. this ends up being square root of 3 over 3. And then when I flip it over, and then when I go to secant, cosecant, I get 2, and I get 2 square root of 3 over 3. These end up being just kind of reflections of each other. These two switch places. Okay, last one, hang in there, you're doing awesome. Pi over 2, which is going to also be a reflection of this top one of 0. So you're going to go 1, 0. You're going to go undefined and then 0. Then you're going to go undefined and 1. And again, all you're doing kind of every possible combination of your point, but with the trig functions. You're doing sine, cosine, tangent, and that is kind of all you're doing. So if you plug those in, that's exactly what would happen. All right, so if you look on your unit circle, the signs for the trig function in each quadrant. So here, everything is positive. Okay, so positive. Well, sine, cosine, tangent. So if they're all positive, if sine is positive, so is cosecant. If cosine is positive, so is secant. Tangent is positive, so is cotangent. None of these are negative. All right, over here. Remember, it always goes cosine, sine for your points. Cosine is first. Cosine is first, sine is second. So for here, what's positive? Well, sine is positive. That means cosecant is also positive. Negative. Well, cosine's negative, which means secant is also negative. Now, I have 1 negative, 1 positive. That's enough to tell me that tangent and cotangent are also going to be negative. How do I know that? Because only one is negative. Similarly down here. All right, I've got 1 positive, 1 negative. But this time, cosine is positive, which means secant is also positive. Sine is negative, which means cosecant is negative. And because one of them is negative, that means tangent and cotangent are going to be negative. Over here, negative, negative, which to me always looks like a sleeping person. I don't know why. What's negative? Well, sine and cosine are negative, which means sine is negative, so cosecant is negative. I don't know why I dotted that. Cosecant and secant are negative. But since both are negative, sine over cosine for tangent, that means it's a negative over negative. That actually makes this positive. And if tangent is positive, so is cotangent. Now, the reason for that is because, if I just take any given point down here, if I go -1, negative square root of 3 over 2, and -1/2, that would be a point in quadrant 3. Well, if I go sine over cosine, and I simplify it, I have negative over negative, which makes that positive. So tangent would technically be, or cotangent, this would be cotangent, because I'd put cosine over sine. That's how that's going to work. So on your unit circle, if you got little spots to say what's positive, what's negative, here's what you want to put. So up here, this is where you would put all, negative, none. So, what's positive over here? It's all the stuff we just said. You should take a minute and write that down, what we've got in all those spots. So here, the only thing positive would be tangent and cotangent. Everything else would be negative. Over here, we've got positive and negative. So remember, it goes cosine, sine. So your cosine is positive, your sine is negative, and 1 is negative, so that means tangent's also negative, and their partners, and their pairs that they match up with. So if we find the exact measure, what are we looking at here? Well, sine of pi over 3, that's the same thing as sine over 60. Or if you can fill out your, you can do the hand trick, or you can do the, if you're good with your unit circle, you can figure this out. That's going to be square root of 3 over 2. All right, so my sine is square root of 3 over 2. Remember, it goes cosine and sine. If nothing else, you will remember that. So secant negative pi over 3. So two things, negative. Okay, so secant of negative 60. Pi over 3, as we kind of established, is 60. So then we flip that around. So it's the same thing as secant of 300. All right, remember, one's negative, one's positive, but they still have to take 360 degrees, get up to 360 degrees. So this is where, they went negative 60 degrees. How far do I have to go this way to line up with that, to be coterminal with that? So that's going to be 300. So then it's secant, so that's 1 over the cosine of 300. So you look, what's the cosine of 300? Well, that's going to be 1 over 1/2. So after all that, I get 2. And again, you can have your unit circle by you towards this. Hopefully you are getting to a point to where you can do the unit circle from memory pretty well without too much struggle. All right, so 7 pi over 6. That's going to be the tangent of 210 degrees. So remember, tangent, this is the hard part, sine over cosine. All right, so kind of my reference angle there from 180 is going to be 30 degrees down here. So that's going to be what over what? Well, that's going to be 1/2 over square root of 3 over 2, but they're both going to be negative. So that's going to be negative 1/2, negative square root of 3 over 2, and then a lot of simplifying later, multiplied by the reciprocal. That cancels out. Multiplying here gives me 2 over 2 square root of 3. So that becomes 1 over square root of 3. So simple, rationalizing later, I get square root of 3 over 3. So that's my answer. That's going to be my tangent of 7 pi over 6. So keep going, find the cosecant of 3 pi over 2. So remember, 3 pi over 2 is going to be 270 degrees. So cosecant of 270. So that's 1 over the sine of 270. Remember the pair, each pair has got one co. So if it's cosecant, that means I've got, it partners up with sine. So if I look at 270, 270 is going to be at 0, negative 1. So that's 1 over negative 1. So my answer is just going to be negative 1. Cotangent of 3 pi over 4 looks like this, or negative 3 pi over 4. Negative 3 pi over 4 is negative 135, which matches up to 225. Remember, one positive, one negative, but they still have to add up to 360 degrees. So cotangent, remember, tangent is sine over cosine, so cotangent is going to be the cosine of 225 over the sine of 225. So where are we located? We're located in, 2 over 2. We're located in quadrant 3. That should be a 2 as well. So you get square root of 2 over 2, square root of 2 over 2, both negative. So after all that noise, you end up getting 1. Last one, tangent of 5 pi over 6. Quick conversion means that that's 150. So you want sine of 150 over cosine of 150. So what does that end up being? That ends up being sine of 150 is 1/2 cosine of 150, negative square root of 3 over 2. So multiply both top and bottom by bottom. That cancels out, that cancels out. I'm left with 1 over negative square root of 3. Let's do some rationalizing here. You get square root of 3 over 3 negative. There's my tangent of 5 pi over 6, which should make sense because, you know, looking at 5 pi over 6, where is that? 5 pi over 6 is quadrant 2, which should make sense. Tangent's negative there. Oop, sorry, back up. So there is your unit circle. You guys should have that maybe not fully memorized, but you guys should be able to build, I would say, at least most of it without too much trouble. Okay, so part 2 of this is not nearly as complicated as you want it to be. Here's the kind of the big thing you need to do. You need to make sure that for once your calculator is in radian mode. So you need to make sure that that is in radian mode, depending on what your calculator looks like. For most, you just need to go to mode and then click on and make sure that it's on radian mode. So if I put in the sign of 1, you should get 0.841 for an answer. Now if I do cosine 0.8, that's going to be 0.697 for an answer. Sine of 1.2 is 0.93. So all you're doing is literally switching your calculator to radian mode and just plugging that in. That's literally all you're doing. So now this is a little more complicated unit circle. What this is telling you though, you know, on the inside you have all your degrees. On the outside you'll notice these are all radians. Okay, so you got all the way back to 6.2, like if you're going around the whole circle. You got back to 6.2, and a little more gets you back to the edge of the circle. This, remember, is your pi, 3.14, and keeps going. Well, all of these represent part of a radian. So this is 1 radian. All right, so how do we use that? Well, let's take a look. So using this, how can we work this? Well, cosecant is 1 over sine of 5. So literally put sine of 5 into your calculator, and you get 1 over negative 0.9589. So 1 divided by that gets you negative 1.043. Tangent of 0.8, pretty simple, type that in, 1.0296. Secant of negative 1.3, remember that's going to be 1 over cosine negative 1.3. So 1 over cosine negative 1.3, all that's going to get you 3.74. Again, all I'm doing, readjusting these if I need to, you know, putting them into the fraction form. And then I'm just letting my calculator do the legwork. I'm just doing some button mashing here. So a terminal point determined by a real number t is given. Find the exact value for the t. Okay, so find the exact value for the tangent. So they give you an ordered pair. Figure out the tangent. Remember, this tangent is sine over cosine. So the tangent's going to be y over x. So this is going to be 3/5 over 4/5. So if I multiply both the top and bottom by 5, that cancels, that cancels. Oops, I backed that up. Sine over cosine, y over x. No, I was right. Hold on. Cosine, sine. So 3/5 over 4/5. Multiply top and bottom by 5. Cancels, cancels. I get 3/4 for an answer. For letter B, same idea. y on top, x on the bottom. Multiply both top and bottom by 4. Cancels, cancels. Negative square root of 11 over negative square root of 5. Now rationalize. Multiply both top and bottom by square root of 5. So you get negative square root of 55 over 5. There's your answer. C, we'll skip for now. You guys get the idea. But basically go square root of 13 over 7 over negative 6 over 7 and work from there. But in the interest of time, we'll keep going. So, find the quadrant that the terminal point lies in. So your answers here are just going to be 1, 2, 3, 4. So sine less than 0, cosine less than 0. That means they're both negative. So where was sine and cosine both negative? I'm really hoping that you're mouthing to yourself quadrant 3. So where cosecant is positive, secant is negative. Remember, cosecant is 1 over sine. Secant is 1 over cosine. So you're really saying, where is sine positive and where is cosine negative? So where is sine positive, cosine negative? So that means you're going to have negative x, positive y. That's going to quadrant 2. Tangent is going to be greater than 0. Secant is going to be less than 0. So secant is 1 over cosine. So you want your cosine is less than 0. All right, and your tangent is greater than 0. But cosine's negative. Well, if cosine's negative and tangent's positive, that can only be quadrant 3. That was the only, if this is positive, but your cosine's negative, then if cosine is negative, so then your sine has to be negative 2 for tangent. Although sine would go on top. All right, so take a minute, go back and rewatch things if you need to, but you should be able to kind of figure out what that is. All right, so here, talking a little bit about basic inverse equations. And basic inverse equations, I know inverse, you say inverse and all of a sudden everybody's scared. The big punchline here is, you got to remember, cosine and then sine in your ordered pair. All right, and here's what I mean when I say that. Sine of x is 1/2. So what I need to do is figure out where is sine positive 1/2. Well, it's going to be positive 1/2 here. It's going to be positive 1/2 here. So what is my value? So my value here is going to be pi over 6 or 5 pi over 6. That's going to be my options. Those are the only two places on the whole unit circle that it's going to be 1/2. All right. So what the heck does inverse actually look like? So arc sine is what it's sometimes called. Sometimes it's called inverse sine function. That's this guy. And all they're saying is this. This is kind of the big punchline. Sine inverse of x equals y, then sine of y equals x. Basically, the x and the y switch places. Sine becomes positive. So what you're looking for is, where does sine equal 1/2? Where does sine equal 1/2? Right there and right there. Because if I were to say the sine of pi over 6, you would tell me positive 1/2. If I would have said sine 5 pi over 6, you would have also told me 1/2. That's all they're saying. So basically, you have to look around your unit circle and figure out, where are these values showing up? Where's 1/2 showing up? Same thing for cosine. All right, so if I had cosine inverse, cosine of square root of 3 over 2, cosine inverse square root of 3 over 2, you need to tell me it's right there and it's right there, pi over 6, 11 pi over 6. That's my answer. That's what I'm doing. All right, so if we look, sine of x is pi over 2, pi over 2, or square root of 2 over 2. So cosine, sine, where does my second one equal square root of 2 over 2, positive? So looking around your unit circle, pi over 4 is the 1. And you're looking for sine, so your second one. So it's going to be 3 pi over 4. Notice, they're asking for your answer in radians, so don't give me degrees. Here, cosine of x is -1. Where on your unit circle is cosine -1? That only happens at one place, pi. That's the only place where the cosine of x is -1. Moving on. Tangent is x. Okay, if tangent is -1, what is x? So you have to remember you're looking for tangent, so that's sine of x over cosine of x equals -1. So what you're looking for is where is the top and bottom -1. Okay, so where you're looking for is where are the sine and cosine the same thing, except one is positive and one is negative. So I could either have positive over negative, or I could have a negative over positive. But sine and cosine have to be the same thing. All right, so the only places where they're the same thing is here, 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 and here. All the 45 variations going around the circle. But I need one positive and one negative. So that means I need here and I need here. So my answers is going to be 3 pi over 4 and then 7 pi over 4. That's going to be my answer. All right, degree mode, it would be 135 degrees and 315 degrees. But my big picture is, where can I get -1 here? Well, I have to think. I have to think that sine and cosine would have to be the same thing, except one would be positive, one would be negative. Inverse tangent is going to look like this. So tangent of y equals x. So if I'm flipping those things around, similar to arc sine and arc cosine, but the punchline is you got to remember that it's going to be sine of x over cosine of x has got to equal whatever this is. All right, that's kind of what I'm trying to do. So somehow I've got to get -1, so sine over cosine's got to equal -1, which is not easy. So tangent of x equals square root of 3. So just kind of working this backwards a little bit, or kind of working the problem. Sine of x over cosine of x would equal square root of 3. One variation of that would be square root of 3 over 1. So looking around, square root of 3 over 1, but that doesn't always work. But we do have square root of 3 over 2 over 1 over 2. So where is the sine equal to square root of 3 over 2, whereas cosine equal to 1/2? And how did I get from here to here? Well, square root of 3 and 1, we don't really have in the unit circle. All right, we don't have those in the unit circle. The closest thing we do have is that and that. Those are the closest things we have. So I'm trying to think about what pieces in the unit circle that do I have that are equal to this. So square root of 3 over 1, I know it looks more complicated. Technically, it is equal. Okay, so I'm looking around for where can I do that. All right. So x would be equal to the tangent inverse of square root of 3. If I do that, what am I going to get? So looking around, where do I have square root of 3 over 2 and 1 over 2? I've got it at pi over 3, but remember, I'm going to have two of them. So I've got to go directly across, pi over 3 is up here, go directly across all the way around or add a whole pi, so I get 4 pi over 3. So square root of 3 over 3 obviously gets a little trickier. So sine inverse of x and cosine inverse of x. So where can I look for that? Well, that one's not going to be easy because I've got square root of 3 over 2 and 3 over 2, but that doesn't help me. This one, because I've got 3 here, this one I actually want to get really clever because I almost want to unrationalize the denominator. What I want to do is recognize that this is the same thing as 1 over square root of 3. Those two things are the same. So it ends up being 1/2 over square root of 3 over 2. All right, so if I kind of unrationalize, go backwards, realize that this rationalize would be that, I can kind of recognize that if I switch that around to get there, I can get there. So what I can do is look around and say, where do I have 1/2 over square root of 3 over 2? Where in my circle do I have that? That's going to be at pi over 6 and 7 pi over 6. There's my answer. That's what I'm doing. I know, these two are tough. Tangent is tough because you got to get a little creative about how you do things. So, sine inverse, what happens if my angle comes out negative? So, sine inverse is negative square root of 3 over 2. So, where do I have negative square root of 3 over 2? I kind of treat it like a regular angle. So, where is the sine, the square root of 3 over 2? Well, that's at 60 degrees. But it's negative, so it's actually negative 60 degrees. So what's my terminal angle? The actual terminal angle is going to be 300 degrees. So find the other solution. Remember, there's going to be 2. So I've got square root of 3 over 2 negative. So this is going to be 5 pi over 3. So that's going to get me to 300. All right, so 300. So 300 is 5 pi over 3. And then I've also got to think about where else is sine negative. Where else is sine negative? So over here, it's a 60-degree angle. So where else is sine negative? Sine is also negative over here. So where is this 60-degree angle? Well, that's going to be at 240, which flop back into radian mode is going to be that. Okay, what happens if the angle comes out negative? So think back to where we were looking at. Tangent inverse is negative square root of 3. Not written like that. Negative square root of 3. So tangent inverse of just square root of 3 would just be 60. So that means our tangent's going to be negative 60. Our coterminal would be 300. Then realize for tangent, if I'm at 300 degrees, I need to go back 180 degrees to 120. All right, so then I can do a little converting here. So what are my angles? So I've got 300 and I've got 120. Well, my angles then are going to be 2 pi over 3 and 5 pi over 3. So again, this is where I went. Let me back up here because I feel like I'm kind of jumping all over the place. So this is where you've got sine of x, cosine of x, square root of 3 over 1. This is where you'd make that jump to square root of 3 over 2, 1 over 2. So that gets you to 60 degrees. Realize it's negative, which gets you to negative 60 degrees. Then if I'm at 300, then I got to go back 120 to get my answer. So flipping it around, I got to subtract 180 or subtract a pi out of here. So my answer becomes 2 pi over 3. Okay, so let's take a look at the homework assignment. So for 2-5, this is where you got to find the exact value. So all you're doing is, cotangent of pi over 6. Remember, cotangent is cosine over sine of pi over 6. So what is that going to equal when I figure it all out? All right, so that's kind of all you're doing for that one. So have your unit circle handy, or if you can build it, that would be awesome. So cosine of pi over 6, which would be square root of 3 over 2 over 1/2. So that's just going to be square root of 3. That's all you're doing for these, okay? Exact value, meaning no decimals. So what I'll say to do is I'll say to skip these 4 in here. Just to kind of shorten some things up. Skip those 4 in here. Make sure you try the negative ones and see kind of how you do. Backside. These should be easy. All you do is plug them in your calculator. These, tangent, remember, sine over cosine. It goes cosine, sine. So just take the second one over the first one and see what you get. You can skip 24. And then these last 3 shouldn't be too bad. For here, let's see. We'll get rid of number 5. And then get rid of these last 3. Okay, so that's all you're getting. That's kind of what you're, excused from doing for your assignments.